Strange fruiting bodies, dusty spores, overwhelming speed of infection, strange roots. In The Last of Us, it is clear. The zombie apocalypse that has destroyed a major part of humanity, killed billions of human beings and turned the world into a post-apocalyptic mess is nothing else than fungus infection. Hi, I'm a fungus-obsessed person who also loves video games, and today I want to dive into something that includes both mushroom science and video games. The Last of Us. Today, you and me are going to discuss the differences between the fungal infection portrayed in The Last of Us and actual real-life fungus behaviors and characteristics. Is The Last of Us accurate? Or is it straight fantasy? Can this really happen to us? And if it can we fight it? Fun fact, The Last of Us is actually the thing that got me to wonder about fungi and mushrooms, later making it my special interest. I could not take fungi out of my mind from the moment I learned that fungus infection in The Last of Us was not entirely fiction. And then I fell into the rabbit hole of mycology. You never know enough about fungi. Anyways, in the fungus world, we are familiar with parasitic mushrooms infecting plant hosts like trees, infecting us in the form of an uncomfortable itch between your toes, for instance. I'm sorry about that. Or even insects. The simplest definition of a parasitic mushroom or organism is an organism that takes nutrients from another host or uses it to reproduce, at the host's expense and without giving anything back, resulting in the host's decrease in health or its eventual death. But parasitic mushrooms don't stop there. Out there is a specific division of parasitic mushrooms infecting insects that don't simply disable or kill their hosts for nutrients, but will keep its host alive to use it to its will, turning the insect into a puppet, a zombie. And this fungus is called cordyceps. Before going any further, I want to address that I do not have a degree in biology or mycology. I'm just a fungus enthusiast who reads a lot of books, picks and examines mushrooms as a hobby, and learns about mycology in their free time. My analysis goes as far as my knowledge. Do feel free, though, to add or correct anything in the comments if you have better knowledge than me. That will make my day. And that is as long as you're being nice, obviously. This video contains some spoilers of the first and the second game of The Last of Us and some episodes of the HBO series. This video contains graphic images of infected insects, but no worms, for personal reasons, and spiders. There will be a warning on the screen when that happens, so you know when to brace for impact. Enjoy! I will be talking a lot about mushroom biology, ecology, and anatomy, so I'm going to fill you up real quick if you don't know anything about fungi. Let's go. A traditional looking mushroom is composed of 1. Mycelium, which are thousands of tiny cords forming a network and is made of hyphae. 2. A fruiting body, which is what we see outside of the soil with sometimes a stem and a cap that can have pores, gills, or teeth. And the fruiting body is what spreads the spores, which are microscopic, that usually fly into the air to get to its destination and form a new mushroom elsewhere. You can compare spores to pollen for plants and flowers. Now you know what you need to know for this video. In The Last of Us, we understand that what has infected the major part of humanity is a species of fungus, the cordyceps. In the game, the fungal infection that touched humanity is described as the cordyceps brain infection, which is already something we might question later. In the game and in the series, we know that the cordyceps came from infected crops, itself infected thousands of products shipped all around the world. In The Last of Us, cordyceps is described as a fungus spreading its mycelium through the human host's body, muscle tissues, and eventually and supposedly brain, while the human is still alive, so we're not really talking about zombies here, zombies being live dead people. The fungus is known to cause twitches in the host once entering its tissues, and when it reaches the brain, it can control the host to make it move and behave the way the fungus wants, with one intention in mind: spread the infection and reproduce, and therefore bite whatever is on its way. So what is cordyceps? In real life, I mean. What mushroom is that? Well, if you start looking at mushrooms and mycology, you quickly realize that this is fungus, but this is also fungus, and this, and that too, yeah, and this one as well. Fungi are everywhere, on the ground, on wood, on soil, on rocks, in the air, in your food, all over you. And that is partially linked to their extraordinary ability to adapt to almost any environment, where they prosper and reproduce. If we keep it simple, we can say that there are three main ecologies in fungi. First, mycorrhizal, when fungus interacts, fuses, or exchanges with a plant partner to get nutrients. Then, saprotrophic, when fungus decomposes dead organic matter to get its nutrients. And finally, parasitic, well, you guessed it, when fungus gets its nutrients from another organism, endangering it or killing it. In real life, cordyceps is a genus of parasitic ascomycete fungus known to infect insects and arthropods like ants, flies, spiders, caterpillars, wasps, etc. The genus Cordyceps includes over 400 different species and is not the only fungus known to be a parasite to insects, but anyways. You might know the famous Cordyceps militaris, used in many food supplements and medicine for its health benefits. So for now, we go from this to this. But it's not just any type of Cordyceps that inspired the game and the series. Ophiocordyceps unilateralis, from carpenter ant to man. The Cordyceps in the series is identified as a genus called Ophiocordyceps unilateralis, and is the inspiration taken by Naughty Dog to create the genus of Cordyceps in The Last of Us. Ophiocordyceps unilateralis is a parasitic genus of cordyceps that specifically targets carpenter ants, mostly in tropical forests. The fungus infects an ant with its spores, taking control of the ant's body, leading it away from its colony, to eventually make the ant anchor to a leaf way below the colony, in the perfect, dark, and moist conditions for the fungus to grow and spread its spores, killing the ant. Scientists have found thousands of infected ant cadavers on low tropical forest grounds. Naughty Dog developers shared that they got their inspiration from a BBC documentary featuring an ant being infected by Ophiocordyceps unilateralis, turning it into what people call a zombie ant. In the series, episode 2, on the day of the outbreak, an Indonesian mycologist is called to identify what fungus caused the infection of a dozen people, and she claims that this is a sample of Ophiocordyceps unilateralis, a genus that can normally only affect ants, or at least insects, except here the sample was taken from a human body. So, how does this transition from the carpenter ant to the man happen? How does it work on a human body? 'Cause let me remind you that we are switching from an insect host with an exoskeleton, a body and a system that functions differently, a body that differs by size, temperature, and anatomy from a human. Now that we know what genus of cordyceps we're dealing with, we're going to compare the game and real life based on Ophiocordyceps unilateralis, and fungal behavior in real life in general. Part 1. The infection. 26th of September 2003. Crops suspected of having been infected by Ophiocordyceps, probably from flower worms or spores, were turned into hundreds of different products, shipped and sold all around the world. People consumed it. Then they started feeling sick. Before they know it, they, too, became infected with the fungus, turning into aggressive and uncontrollable monsters. Then, they started biting. That is how the infection is believed to have started in The Last of Us, and how the worldwide reach of the infection is explained. In the series, there is a shot on Joel's neighbor feeding his mother floury biscuits, and we later see that Granny convulse and twitch in the background, already infected with cordyceps that was in these biscuits. They later mentioned that she might have been bitten in the hospital, but I think they would have noticed earlier if she had. In the game, a human can either be infected directly via a bite from an infected, or indirectly by breathing airborne spores released by cordyceps mushrooms growing on infected corpses. Both methods are extremely quick, turning the infected host into a runner in a matter of hours or minutes, depending on the area that was bitten. Indeed, in the game and in the series, we can find posters indicating the time left before the person turns into a runner, depending on where the bite is located. If it's on the leg, you still have a day. If you got bitten on your upper body, you've got several hours. But if your bite is on your neck, face, or your head, you might start losing yourself in a few minutes. I think the bite just serves as a way to open a wound to transplant either spores into the wound or mycelium, given that infected have mycelium coming out of their mouths, somehow. Now, if we compare this to real-life Ophiocordyceps unilateralis, there is one common point: spores. The fungus uses its spores to infect ants, but it doesn't wait for the ant to ingest or inhale the spores like we saw before. It penetrates directly into the ant's exoskeleton. Once infected, ants are immediately taken over by the fungus and start walking away from their colony. Also, infected ants don't bite other ants. The ant's body is only used by the fungus as a vessel to later attach to a leaf and develop its fruiting body and release its spores. Runner, clicker, bloater, shambler, or even rat king all represent different stages of the cordyceps infection, and depending on who you walk into, your fate can be really different. In The Last of Us, we recognize 4 main stages of infection. We'll talk about him later. These stages basically represent how advanced the cordyceps has become and how far it has developed in the host's body, depending on how long the body survived. You can even find posters by Federa detailing these stages. Now let's take a good look. Stage 1. The runners. Cordyceps has taken over the victim's motor functions, fast and agile. Stage 1 infected usually travel in packs. Do not let them swarm you. So this is the first stage of infection after a bite or the inhaling of spores. Runners are dangerous because they can see, they can hear, and they can run. They run fast. However, since the cordyceps fruiting body has not yet taken over the infected face and skull yet, they are not very resistant and can generally be killed with a headshot. They're the most human looking, as their voice is still intact, they're moaning or screaming, not clicking or croaking, and they still have what looks like facial expressions, as if they were trying to fight off the infection, or as if they were in pain. Stage 2. The stalkers. Uses environment to hide and ambush victims, will frequently flank and attack from behind. Approach with caution and check your surroundings. This is the second stage of infection, usually happening between 2 weeks and a year after being infected. As their name suggests, they are not bluntly attacking their prey anymore, being loud and predictable. They stalk. They hide and wait for an opportunity to sneak attack their prey. They plan, they wait, they watch, they listen. They sometimes attach themselves to walls so the cordyceps can develop until someone comes around, someone to hunt. This is one of the most dangerous stages, because it is the perfect balance between the thorough development of the fungus and the human body that is still preserved and able to see, hear clearly and move freely. What I mean is that the fungus has had time to reach the infected's brain and therefore completely hijack the host's body and its mind, making hunting strategies and planning ahead, but the fungus has not yet overlaid the body's head, preserving its eyesight. The infected is not a victim of the cordyceps anymore. It's the infected making choices. The cordyceps and the human body are now one. I think this stage represents fungi the best in its survival and hunting strategies. Indeed, you might think of fungus as a sort of barely animate pseudo-plant, just absorbing nutrients, growing and reproducing. But the fruiting body of a mushroom is just the emerged part of the iceberg. Fungi are entire networks, communicating information through pulses, making trades with plant partners, making up strategies to trap and hunt their prey, tricking other organisms. Fungi change. They make choices. They adapt. They understand. Fungi are giant brains just beneath our feet. Stage 3. The clickers. Completely blind, acute hearing, uses echolocation to seek out prey. Keep your distance. Stage 3 infected are known for their ferocious attacks and are extremely lethal. This stage happens usually after a year of infection, the cordyceps fruiting body having taken over the entire head of the infected, sometimes even splitting the skull in two. The infected can no longer see, and it is made up for by a very acute hearing. They also gain in strength and aggressivity, which makes them extremely dangerous to fight in close range. Also, as their name suggests, they produce clicking sounds, which are a very nice vocal stim, by the way. That was my impression of a clicker. Me sorry, this won't happen again. This clicking sound is probably the human's vocal cords having mutated, and clickers use echolocation to navigate and find prey. That's also how they know where other clickers are, and it's probably their way to communicate with each other, cordlessly. Just like fungi usually use their mycelium to send signals to other mushrooms and plants. I wonder if this is an interpretation of how fungi would communicate with each other if they had a voice, or if it's just a scary aesthetic feature of the infected zombies and they didn't think further than that. Stage 4. The bloaters. Rare but dangerous evolution of Stage 3 infected. Incredibly strong and capable of throwing acidic projectiles. Do not engage unless absolutely necessary. So, the bloaters are something, alright? Ew. Even their name, bloaters, gives bowel movements and, I don't know, farts. They are very rare, as they are a late stage of infection, usually occurring several years after the infection. The fungus has now completely covered the body, making them blind and slow, but also extremely resilient, the mushrooms acting as an armor. They're usually seen as a sort of a boss fight, especially the first encounter with one in The Last of Us first game, because of how hard they are to kill. As if being a giant fungus monster wasn't enough, they can detach mushrooms' parts of their bodies with a sort of acid inside and throw them at you, which makes additional damage. However, their extended fungal growth catches fire easily, which is their weak point, I guess. Now, there are some variations to the bloaters introduced in The Last of Us 2, called the shamblers. Due to the fact that they inhabit places with large amounts of water, they seem to have developed further than other infected in dry areas. You know, they got the moist. They also throw acid balls at you, but they can also spray gaseous acid when near the player, which causes extreme damage. If we make a quick little accuracy test, we could say that fungi are able to produce acid. That's how they break through matter such as soil, wood, or even rock. So I guess this might be a mutated new way to use this acid, stored in little pustules that they can shoot at their prey. Fungus, final boss. And then there's this guy. Or these guys. Ugh. How to forget the Rat King when it took me days to finish him. I was so scared. The Rat King is described as this mutated infected form where several infected people stay trapped in the same area together with their spores, unsupervised for so long that they fused. It is extremely hard to kill, given that it just splits into individual bodies when taking enough damage. And it's often stalkers. Now, can mushrooms fuse together? Well, in theory, absolutely. When mycelium from two of the same fungus meet, it can fuse and share DNA. And about the splitting into a separate body thing, I guess we could compare that to when fungi split their mycelium into smaller fragments to form its own mycelium network, but it's barely a similar process, let alone identical. Again, it's terrifying, it's sensational, it's for fiction. Okay, so that were the main stages of infection that we can see in The Last of Us. Now what's it like for our little carpenter ants? Now, I want you to use a bit of your imagination and listen to me. Imagine you're a carpenter ant. No, hear me out. You're a carpenter ant, working with your colony, just doing your job, as an ant. Meanwhile, something is in the air. Something dusty, lurking around you. And before you realize, it's on you. Spores. What you don't know is that another ant like you is lying dead, upside down on a leaf, overcome with the deadly parasite. And now it has fruited, and now it's coming for you. The spores have already penetrated your body through your exoskeleton. There is no turning back for you. The yeast stage of the infection. You're still an ant, by the way. The yeast stage of the infection is spreading in your body and is producing compounds that affect your hemocoel, the cavity where your fluids circulate. You start twitching involuntarily. A disease? Death? No, it's worse. Because it doesn't stop at twitching. Wednesday conversation. Your own behavior becomes stranger and stranger. Your muscles and limbs start moving by themselves, as if controlled by an invisible thread. Pulses, an invisible force driving you away from your beloved and secure colony in the high nest to the forest floor. Your fitness is increasing, but not for your benefit. Once you're deep down the forest floor, where it is dark and damp enough, you stop. Or rather, it stops. Now you start biting. Your mandibles anchor themselves in a leaf and clench with an incredible strength you have never been able to achieve before. It's like something invisible is pressing your mandibles into the leaf. Thursday is pathetic. You are now paralyzed. Now that you are in the perfect environment, the conditions are met for the fungus inside you to grow. Before it kills you, you see the hundreds of other ants like you, dead, white, with mycelium, a little fruit coming out of them, your fate. In real life, unlike in the game, the ant is not a vessel, just soil for the fungus to grow, and by growing hyphae into the ant's soft tissues, it fortifies its exoskeleton. I guess we can compare that stage to late stages of infection in The Last of Us, as people's external envelope is stronger and more resistant thanks to the fungus, just like the ant's exoskeleton. Part 2. Infected behavior. So now it's time for the bigger questions. How does that happen? How can a fungus growing from microscopic spores make you act against your will and turn you into a deadly zombie? In The Last of Us, the infection is described as a cordyceps brain infection. At first that sounds quite right. If a parasite can control your movements and make you behave to its will, it must be going on in your brain. Now, if we look a little deeper into instances of cordyceps infection in The Last of Us, and if we assume that, as the developer said, this cordyceps is a mutation of the Ophiocordyceps unilateralis, we might find other answers. In the first minutes of episode 2, we have a very interesting scene about a TV show in 1968, where people discuss epidemics and viruses and the potential cause of humanity's downfall, and of course, fungi entered the discussion.
For example, travels through its circulatory system to the ant's brain and then floods it with hallucinogens, thus bending the ant's mind to its will. The fungus starts to direct the ant's behavior, telling it where to go, what to do, like a puppeteer with a marionette.
The scientist compares parasitic mushrooms with LSD and psilocybin, a compound in some mushrooms used for LSD and other mind-altering experiences and trips. He blames the ability of the fungus to control its host on hallucinogens and mind-controlling tricks. Now, if we look at Ophiocordyceps, it has been found to produce the family of chemicals that LSD derives from, and this part of the fungus is activated in infected ants. So hallucinogenic properties may have something to do with the ant's behavior. Right. Okay, good. We have a theory. Cordyceps messes with an ant's brain with hallucinogenic compounds. The only problem is, there is no Ophiocordyceps in an infected ant's brain. Yes, scientists have been surprised to discover the absence of the fungus inside an infected ant's brain. Well, that is, before it kills it and swarms the ant's insides with hyphae, of course. The Ophiocordyceps only takes control of the ant's central nervous system and gets rid of the ant's instinctive fear, but it's not in the brain. That was a tough sentence to pronounce. The potential use of hallucinogenic properties and the absence of the fungus in the host's brain remains a mystery. In the game and series, they do claim that the cordyceps infects the brain, which is a possibility. After all, the central nervous system is located both in the brain and in the spine. So, let's just forget about the brain for now. Another theory to explain Ophiocordyceps is the extended phenotype. The extended phenotype theory suggests that the fungus is able to manipulate the ant's movements through its limbs and muscle tissues, rather than influencing the ant's choices and thoughts. The fungus moves the ant's limbs against its will. That's right, like a puppeteer. But it goes further than that. A puppeteer controls you from the outside, with strings. Here, it controls you from the inside. It possesses you. It's not an ant anymore. It's Ophiocordyceps in the envelope of an ant. The ant becomes a mere prosthetic for the fungus to achieve its goal. And I think it's the exact same thing in The Last of Us. In the game and series, it is clear that at a certain stage of the infection, cordyceps has already taken over most soft tissues. Take for instance a clicker. The fungus has taken over the brain, sometimes even cracking the skull open and spilling its mushrooms out. From a certain point, it's not a human infected with cordyceps anymore. It's cordyceps living in a human body envelope. In the series, episode 2, when the mycologist examines one of the dead infected victims, she cuts through her bite mark, only to find a layer of mycelia. The cordyceps has already made it up to her mouth, and this only 30 hours after her infection. The cordyceps takes over your body really quickly, and you are not in control anymore. You are just an extension for the fungus. Oh, and food. Part 3. Feeding. Food. Because cordyceps doesn't stop at controlling you. It eventually eats you from the inside and replaces your soft tissues with its own. You are soil for cordyceps. You become a cordyceps farm. However, there is a question that always pondered in my head when playing or watching The Last of Us. It's an infected behavior that we mostly see in backgrounds in the game, a little more obvious in the series. Infected eating people and animals. Nobody really mentions it or comments on it, but it does happen a lot. And this is really interesting, because real Ophiucordyceps unilateralis kills its host as soon as it reaches the right spot. But in The Last of Us, the infection doesn't kill people. In the contrary, it makes sure that the body survives. The cordyceps doesn't use its host just to bite other people until it's too weak to prosper. It survives. Once it has already taken over most host tissues and muscles, it hunts for nutrients. But it can't eat the body just yet. It needs it. I think that's why they eat people and animals. Because the fungus needs to keep its vessel fueled. It keeps the heart beating and the blood flowing. We can now come to say that infected people in The Last of Us are hybrid beings, both functioning as a fungus and keeping the minimum requirements for the human body to survive and maximizing its chance to use this body to bite other people and spread the infection. Once the host is dead for whatever reason, the fungus isn't. One of its vessels is just out of service. It can now eat all of its tissues and spread its spores, often anchoring on walls to spread its fruiting body. We may compare this to the Ophiucordyceps anchoring the ant's mandibles into the leaf to fruit and spread its spores. So we've come to the conclusion that infected humans are merely a vessel, an extension of the fungus, a hybrid being. Which leads us to the famous question. Is it still you in there? Are many factors and clues leading us to consider that infected people are still people inside. Some infected people moan, some scream, some are seen to be startled by gunshots, and some scream in pain when on fire, which can make killing what seems at first glance a scary primitive zombie monster difficult. Is the infected human still in there? Is there anything remaining from the person, the individual that was perfectly sane 24 hours ago? It might be true for runners, given that the fungus hasn't replaced their brains yet. They're the ones that look the most human. They moan all the time, they sound scared, and they have facial expressions. After all, the fungus is still in early territory invasion. However, it is still too late. No need to try the "come on, look at me, snap out of it" technique. It won't work. The fungus is now the boss, and there's no turning back. For later stages of infection, like stalkers, I honestly don't think there is any human remaining. The infected is actively hunting its prey, being stealthy and making hunting-related choices. It's not forcedly following the fungal pulses in its muscles anymore. It's giving in. Besides, given how some stalkers have mushrooms sprouting from their heads, high chance the cordyceps has overcome the brain already. Needless to say that clickers and bloaters and so on are not human anymore. Their body is almost just fungus, their voice is changed, their behavior is closer to a flatworm hunting fungus than to your average person. But what is interesting is how they kept human reflexes, such as screaming in pain or being startled. Perhaps the fungus valued the human's defense systems as beneficial for its survival and did not destroy it. I hope the way this video unraveled was easy enough for you to understand. There are some points though that I just couldn't fit in my outline, so now it's time for random questions. Question number 1. How do they test the cordyceps? In the game and in the series, we see a device used by Fedra to perform a cordyceps diagnosis on people. The device is a sort of electronic scanner that tells you in seconds if the person is infected, with a red screen and little beep sound. So how does it work? And how can it detect the infection? So what happens is that you press the back of the scanner on the neck or behind the ear, you click and wait for 3 seconds to see the result. It was a little unclear in the game as to how the scanner can detect the infection, but given the reaction of people in the show, seeing how they flinch during the diagnosis and how the Fedra agent told the kid that it's going to sting a little, it's possible that it's a needle and therefore a blood test. The blood test theory is confirmed with this medical pamphlet that you can find in the museum in the first game. Now, I don't think my knowledge goes as far as to tell you how exactly does the technology detect fungus in the infected's blood, but I figured that in the decades following the outbreak, they had time to conceive that sort of diagnosis technology. Question number 2. Does cordyceps love, as the pedo freak suggested? By pedo freak, I of course mean David, the church leader of that one group in The Last of Us. He doesn't mention that in the game, but in the series, he claims that the cordyceps is not so different from them humans. It kills to survive and to reproduce, to protect itself, and he comes to the conclusion that it loves.
What does cordyceps do? Is it evil? No. It's fruitful, it multiplies, it feeds and protects its children, and it secures its future with violence if it must. It loves.
I thought about what he said for a while after watching the show, but honestly, I think he's just being a freaky ass. I don't really see fungi as individual entities, individual organisms. He says it feeds and protects its children, but it doesn't. It creates children, yes, if you see reproduction like that, but then the new fungus is independent. It's just one other limb of the whole machine. They expand so much, they can fuse with themselves, it can fuse with itself. For me, a species of the same fungus is one, only separated by a distance before it finds itself and fuses. There's no concept of other in one genus of cordyceps, in my opinion. It kills and reproduces to expand and survive. Is it self-love then? Maybe. But anyways, I think he was just trying to make a weird point to justify eating people. He didn't need to go that far. Eating people is okay, as long as they're okay with it. Well friends, I think that marks the end of the first episode of this podcast. Don't worry, this isn't the end. I have plenty of other topics to cover about the cordyceps in The Last of Us. Next time, we'll talk about cordyceps anatomy and appearance, about cordyceps networks. We will discuss the famous question, can this really happen to us? Is The Last of Us a premonition of humanity's downfall? And if so, is there a cure? Is there such a thing as immunity, like Ellie demonstrated? Stick around to find out. Thank you so much for watching all the way to the end. If you want to make me really happy, you can share this video to fellow The Last of Us or fungus lovers, or to your friends that might be interested in this video. Well, remember to stay hydrated, to crush out your government, and I'll see you next time on Micro Robbie.